Hello. So if you've been following our channel, you might have noticed that we've covered quite a few videos on how to use drones for building inspections and 3D model capture, and also how to use drones for AI. However, when it comes to capturing large industrial sites, there's a few things you need to keep in mind to create high quality 3D models. These large industrial sites could be things like power plants, entire areas undergoing redevelopment, or even shopping malls and parking lots that need to be captured using drones. So in this particular video, we're going to be looking at the end-to-end workflow on how to capture a large area using drones, and we'll be using the Mavic 3 Enterprise for its agility and battery life to be able to cover large areas in a fraction of the time. Let's have a look. So we'll be using Hammer missions for this project. If you haven't got an account, you can create one, but I've already got one here, so I'm just going to log in. Once I've logged into my account, I will go into mission planning because the first thing I want to do here is to set up my flight plans. Once I am in the mission planning interface, I can then start planning my shopping mall capture. So, as you can see, I've set up a folder over here, and that's basically a large shopping mall capture with the Mavic 3 Enterprise. I've already got two different flight plans in here, but because I want to walk you through the entire process, I'm actually going to start from scratch. So I'm going to start a new mission file. So I'm going to call this one, let's say, full site capture. And this mission file essentially allows me to be able to essentially, if I open this mission file, it's going to allow me to actually define the entire site. So firstly, if you see on the screen, you'll notice that there's essentially a large site on Google Maps that has popped up on my screen. And this essentially is a site that we'll be capturing today. You can already tell from the footprint of the site that it's quite a large site, and therefore it's going to be really important to make sure you make the right decisions with the mission planning so that all of those essentially pay dividends when you've got to do with your 3D modeling and to be able to actually create the digital replica of the site that you can draw insights from. So to start with, what you're going to do is to do the full site capture, we would recommend using the 3D modeling option in Hammer Missions. So there's a little tooltip here that gives you more options in terms of explaining what that option does. But if you choose that option, you can then essentially draw a polygon covering the entire site. Now, you basically need to follow the geometry of the site to be able to create this polygon. Essentially, every single corner of the site, you can draw this polygon. You don't have to sort of get every single corner, but you need to be precise enough that you've got the area that you really wish to capture under that polygon. So once I've drawn my polygon, I can hit enter. And then what Hammer is going to do is that it's going to create a default flight plan for that particular area. So it's gone ahead and done that. Once I have that flight plan, I can click on the settings gear and I can then go and adjust all the settings. Right, so we're going to be using the Mavic 3 Enterprise wide camera for this particular mission, so that's already pre-selected for me. But if you were using a different camera, for instance, let's say if you were using the P1 camera, you can just choose the P1 camera as your camera for planning, and then Hammer will replan the flight plan. But for this particular video, we're going to be using the Mavic 3 Enterprise Advanced, Mavic 3 Enterprise, sorry, and so you can essentially just choose that camera. Once you've done that, you can then set up the altitude for your particular flight. So with the altitude, what you need to understand is what is the height of the tallest structure on site. As we can sort of see, there is a parking lot on the left-hand side over here, and then there is a building on the right-hand side over here. So what we really need to understand is what is the height of that building. So to be able to do that, what I'm going to do is I'm going to pop the coordinates for that building into Google Maps. So I'm just going to exit this menu for a second. I'm going to take these coordinates and I'm going to go into Google Earth. So I'm just going to essentially navigate to Google Earth over here. And once I'm in Google Earth, I can essentially add those coordinates and Google Earth will take me to that particular site. I'm going to let that load. And once I'm on that site in Google Earth, I can actually see the building in 3D, hopefully. If you don't have the building in 3D on Google Earth, you can essentially do this on site. You can adjust the setting and you can take an educated guess on what the height of the building might be. So once we are on site, what we're going to do is we're going to use the ruler tool over here in Google Earth, and we're going to just measure the height of the building. Now, The building does have more or less the same height throughout, and so we don't need to be super precise. We just need to be able to get a simple idea on what is the height of the building. So let's say we're gonna drag this out here, and we think the building's at 12 meters. So somewhere between 12 and 13 meters at this point. If we take the higher point over here, we notice it's at 15 meters. And then we can essentially just look at the facade of the building and try to estimate if there's any other point that we haven't looked at that might be higher than that. But assuming that 15 meters was the height at that point that we sampled, and we're looking at the rest of the facade, and we've got this building here, which is actually slightly higher. So it would make sense to also measure this particular building, just to get a sense for what is the height of the building. So once again, we're going to do our measurement, and this one's at 24 meters, right? So we can then tell that actually the highest point on that particular building is 24 meters. And so that's what we're going to use for our building height. Ideally, we want to be actually a few meters or feet above the tallest structure, as you can imagine, for safety reasons. But at the same time, we don't want to be too close because that's going to increase our flight time. So I'm going to go with 40 meters for this particular building for the moment. So that's going to be 120 feet. Now, on site, we might decide that actually we want to go higher. And in fact, once we've done all the settings, we might change that altogether. So we're at 120 feet at the moment. Ground offset, I'm going to leave that to 0, even though there is a building that we're capturing here, and ideally we should add ground offset, but I think that's going to be less of an issue here because it's a 3D modeling mission for the entire site as opposed to the building itself, and so it's not necessarily needed for this particular task. Front overlap and side overlap, we're going to bring them down to 70%, even though 80% is recommended. Because it's such a large site, and because I want to reduce the total time that it takes to capture the site, I'm going to reduce the front and side overlap to 70%, which will decrease my total flight time and the amount of images that will be taken. Ideally, I want to get this done in one battery, and I want to get this done in about 1,000 images. So those are the targets that I'm really going for. Flight direction. So flight direction in this case doesn't really need to be tweaked. Generally, Hammer will plan with the longest edge of the polygon in mind, but what you're really trying to do with the drone is to essentially capture the facades as you go across in a crisscross pattern. And so as long as you are hitting both sides, hitting the building from both sides of the flight, you should be okay. So we're going to leave that with the default flight direction. Gimbal tilts. So this one's really important because you're trying to create a 3D model for this particular site. What you need to do is, instead of keeping the 3D to be at -70, you want to bring it to, as opposed to keeping it at -90, you want to bring it to -70, where you're essentially adding a small gimbal angle, a small gimbal tilt to your images, which will essentially help create a high quality 3D model, especially with those vertical structures on site, and be able to capture them completely. You want to add smooth corners to your flight. So this flight speed is automatically calculated for you. And reversed flight path is a setting that essentially changes the start point. So at the moment, the flight will start from this corner, but depending on where we take off from, which is basically going to be this parking lot over here, we might want to change that to be the other corner of the polygon. So if I hit that button, you'll notice that the start point changes from that particular point to that particular point. And if we are taking off from somewhere here, maybe we're more comfortable with starting off here and then ending up all the way here and then doing the other way around and then finishing the flight where we started. So that's pretty much it. Show planned images only shows where the images will be taken. So if I was to turn on that option, what it's going to do is that it's going to show me blue dots where images will be taken by the drone. So you can tell each one of these blue dots is basically a point where the drone will take an image. There's about 2,800 images currently planned. So what I need to do is I need to really optimize this flight plan, because at the moment it's 2 batteries, over 2,500 images, close to 3,000, and that's actually an overkill. So what I'm going to do, since I'm under 1 centimeter per pixel in GSD and I have some wiggle room, I'm actually going to go to 160 feet for this flight. So 160 feet will essentially be a higher altitude. It'll give me 1.3 centimeters per pixel in GST. If you don't know what GST is, we have made a whole video on GST. If you just Google GST and hammer missions, you will see a number of links that show up, or just go browse through our other videos and you'll be able to understand what that means and what it's useful for. But basically, if I increase the altitude, you'll notice that the images have gone down, and the batteries and the flight time has also gone down. So my aim is to essentially get this done in one battery. So what I'm going to do is I'm going to increase the flight altitude even further. Perhaps I'm going to go to 165 feet. And that's going to allow me to essentially get the flight time down by a little bit more, and also help with the number of images. Now, another optimization I can make is that I notice over here, I'm capturing some of this road that I really don't need. So I can actually adjust my polygon and essentially bring it closer into the building to be a tighter fit. And that's going to also allow me to actually have a smaller flight time. So I'm just going to do that now. What I've got to be careful with is I don't want to add too many points in the polygon, because that's going to increase the time it takes for Hammer to generate a flight plan. So I want to make sure that I actually balance those two out. Once I've done that, I will notice that the flight time has gone down, but not significantly. So that's what we notice is going to be the flight. So it's 42 minutes, so it says 2 batteries. But I suspect, because given the speed of the Mavic 3E, we might just be able to get away with doing this in 1 battery, because it's only 2 minutes over the first battery, and I suspect, given how fast the Mavic 3 Enterprise actually is, that we'll be able to actually do this in 1 battery. So I'm going to leave this as the default flight plan for the full capture, and we're going to move on to the facade. So what I'm going to do next is I'm actually going to go and create a facade flight plan in the same site. So I created this file over here called the full site capture. Now I'm going to create a new file, and I'm going to call this, let's say, the facade capture. And so what this does is that this one will allow us to actually capture the facade of the building on site, and essentially allow us to ensure that we are also taking imagery off the building from all the different facades, all the different points of the facades, and then create that really high quality 3D model. So what I'm going to do now is I'm going to go into the facade mapping option over here. And once I'm in the facade mapping option, I'm going to draw out the facades for this building. So I'm going to click on the different corners of the building, and just making sure that I'm following the profile of the building. And I don't want to add too many points. I just want to be able to quickly create a flight plan for this particular building, going through most of the corners and ending up with a facade flight plan. So I'm just tracing out the boundary of that building. And what Hammer's going to do now is that it's going to essentially create a facade mapping flight plan. And that flight plan is going to essentially be pointing into the building. So you can sort of see that. You've got a flight plan that essentially looks into the corners of the building, or looks basically into the facade of the building. Once again, I will have to adjust this flight plan to make sure that I can actually cover all of this in 1 battery as opposed to 4 batteries. So what I'm going to do is I'm going to go into the settings for this particular flight plan, change my camera. We've already got the Mavic 3 Enterprise wide selected, so I'm going to leave that on. Flight mode width first means that I'm going to go around the building first and then up and down. So that's correct. That's what I want to do. So I'm going to leave that as it is. Top altitude. So we just determined that actually the top altitude is going to be 164 feet. So we're going to leave that at 164 feet. And because the building's only about 20-25 meters, or about 75 to 90 feet in height, what we can do is we can actually just fly around it in 1 circle, in 1 orbit, or at 1 lateral capture. We don't have to fly it in many different orbits, because we'll be able to see the full facade in 1 ring. If you really want to increase quality, we can go 2 rings or 3 rings around the building, but it might be an overkill given the objective of this particular task. So top altitude 164, and bottom altitude I'm going to bring that to 164 as well. And what that's going to do is that it's going to generate just 1 ring of facades around the building, so it's not going to have multiple rings. And what we'll notice is that actually the images goes from 900 to 164. That's essentially one battery in 20 minutes. So that's looking pretty good. That's what I really want. Gimbal tilt. So I'm going to bring that up to minus 45 degrees. So minus 45 degrees will allow us to essentially capture the facade of the building. And it's going to essentially allow for a gimbal tilt where we are flying above the building, but we're looking down at an angle and still capturing the facade, maintaining a good overlap from the building. Horizontal distance is set to 33 feet by default, but I might want to bump this up to 45 feet. Maybe I want to be slightly further away from the building. Again, improving my overall flight time and reducing the number of images that I need to be able to cover the same area, but maintaining a good, healthy overlap. So 45 feet is what I've gone for the moment, but this might be different for you depending on your site. Maybe you've got something like 60 feet that you want to stay at, or you want to be closer. Really depends on the building, really depends on the conditions. Overlap, so what we're going to do here is we're going to go for 60% overlap on the sides, because we're going to be capturing the sides anyway from the full site capture, but we are essentially adding another layer of images around the facade. So we've got one battery, 231 images, 30 minutes, and it is looking pretty good. The flight speed's at 10 meters per second, which is fine because that's going to be fast enough for us to be able to capture all the images that are required. And we don't want to rotate the points because that's essentially going to generate a flight plan on the inside, which is what we don't want. And we want to see all the plan images, which we already can see on the screen. Now, just to be able to get a sense for what this looks like, what we can do is once we've created the flight plan, we can press this play button over here, and that gives us an understanding for what does the flight plan actually look like in 3D. So you can sort of see that the geometry of the flight, the geometry of the building has been traced out by the flight plan. And if I press this button here, it's actually going to show me the building in 3D, and the flight plan will be following on that particular building. So you can sort of see that in 3D. Now, this is only for one ring of capture. If I wanted, I can essentially go back to my mission. So let me just bring up my settings here and then go to the 3D view. And what we can do is we can change this to be 150 feet. And what that's going to do essentially is going to add another ring of images around the building. And why does it do that? Well, because we're telling the software that actually you want to fly from 164 feet to 150 feet, and you want to keep 60% overlap between the images. So the software calculates, well, that would take two different rows, two different rings around the building, and would allow you to actually capture the facade in two different orbits around that building. I don't like to use the word orbit because it's not strictly an orbit, but essentially what you're doing is you're capturing the building facade by flying around it and looking into the facade. So all of these flights over here, it's basically going to be the drone flying around the building and looking at the building. So well, that's the flight plan for the building. I'm going to move this back to 164 feet because we're going to do only one ring in this particular capture, but you are welcome to do more than one ring to be able to improve quality even further. Right, so we have our flight plans ready, and now I'm going to hand over to Dan, who's going to be flying these missions. So all of the missions are actually stored in Hammer Missions in the folder that we set up. And what we can do is any one of these missions that are set up in this folder, I can bring Dan into my team in Hammer Missions. And once Dan is a part of my team that I can sort of see, I can essentially just share this mission file with Dan. And so essentially I click on the share button, and then I'm able to actually go in and share all of these mission files that I've created. And then Dan can go and fly them with the Hammer app, which works on the smart controller. So what I'm going to do now is I'm going to pause and hand it over to Dan.
Hello, today we will be capturing a large shopping mall using the Mavic 3 Enterprise to create a 3D model of the site. Because it's such a large site, the Mavic 3 Enterprise is well suited for the task because of its battery life and speed. We will also be capturing the facade of the building in a separate mission, having a gimbal tilt of around 70 degrees to ensure we capture the vertical structures on site. Let's take a look.
Right, so thanks for all of that flying, Dan. Now that Dan's done all of that, what I can do on my side is actually I can start looking at processing the data. So once the data's been captured, it's all stored on the SD card of the drone. And what you can do is you can now come to the data analysis tab of Hammer, which I've got over here, and you can essentially upload your data. So I've set up a new folder. So I've called it Large Shopping Center. So I'm going to move into that folder and I can create a new project. Once I create a new project, I can add all of the images. But instead of doing that at the moment, I've actually already done that. So what I can do is I can then go into a project. So I've got this one called here, Large Shopping Site M3E. And essentially, once all of the images has been uploaded to Hammer Missions, you can essentially process all of those images into a 3D model and then do all of your analysis on top of that project. So before I load up the 3D and before I load up the 2D, what I'm going to do is I'm going to show you what the actual capture looks like. So you'll notice that we've got the same building that we saw before on Google Maps. But here on the bottom, we've got all of the images that have been taken by Dan and the M3E, and they have been uploaded to the Hammer Hub. And once the images have been uploaded, what you'll notice is that you'll essentially see a footprint of all the images that were captured. So what you see here is essentially all of these yellow dots, and these yellow dots represents where the drone flew and took an image. As you can see, there are two different flight paths over here. There is the crisscross pattern, as you want to call it, or the 3D modeling mission that was flown. And then there is also the facade mission that was flown, and that's essentially capturing the building by going around it. And both of those have been uploaded into one single unified project. So what do we do next? Once we've done that, we can essentially hit this process button. So if I click on the process button, Hammer will ask me for the desired outcome, and I want to create a 2D map and a 3D model for this particular project, so I can choose that. And then I can also choose to have my images tagged using AI. Now, we're not going to go into AI in this particular video because that's not the goal of this video, but we will make other videos on AI, so feel free to explore some of those videos as they come out. But basically, I can press the process button here, and that from that point onwards, Hammer will start crunching the images and start creating a 3D model. Now, that takes a couple of hours for the size of this project, which is about 1,000 images. It might take up to 10 hours to fully process. So I'm not going to go through that at the moment, and I'm going to show you the end result, which has already been created. So I'm going to get rid of the images, and I'm going to switch to 3D mode, and voila, you've got your site modeled in 3D and ready to be used. And what you'll notice is that the images that were used to create the 3D model are very much available for you to still view. So if I was to zoom in on any part of the 3D model, let's say I want to inspect the parking lot a bit more, we notice that actually this part of the parking lot has a lot of severe cracking going on at the moment. And let's say we want to investigate that a bit more because that is not very good. And obviously we want to be able to investigate that. What you can do is you can click on that part of the 3D model. And then what Hammer will do is that it will bring up all of the images from where you can see that part of the 3D model. And you will notice that because the images were captured with that gimbal angle, there's quite a few images that show that particular point. They will all appear to actually show you that particular point. And then on the right-hand side over here, we can actually go in and zoom on that particular part to be able to look at any levels of cracking or any kinds of issues that are forming on that particular pavement, on that particular site. And obviously this is true for not just pavements, but this is also true for the building. So you can actually go in and look at the building and understand its condition and understand the quality and the inspection that might be required in terms of maintenance, in terms of any kind of work that needs to be done on that particular building. But the essence of it is that you've essentially now got a bird's eye view on the entire site. And to be honest, it's more than the bird's eye view. You've got actually a sort of digital replica of the site that you can really work with. So if I wanted to understand what is going on with this roof, any point in this roof, again, I can just click on that part of the roof, and then it will bring up all the images to show me that particular part of the roof. And if I've got issues that I want to annotate with respect to anything that I see on the roof, so going back to, let's say, this part of the roof, and I want to look at, well, trying to see what I could find here actually. But let's say I see some water leaking over here from the air conditioners. And let's say I want to annotate that, maybe because we've got a suspected leak on the roof somewhere. So I can sort of go in and actually mark that up and sort of say water leak, and maybe that's a severe issue that we need to track. So that's going to be tracked. But at the same time, as opposed to just doing condition surveys, you can also use the 3D tool to essentially do your planning. So you can plan out different things on this particular building and understand what you would like to do over time. Maybe you've got different things that you want to do in this particular building, and to be able to do that, you can use the 3D model and the 2D map as a planning tool to essentially come up with all the different types of plans that you'd want to make with this particular site. All in all, the 3D just gives you this great sort of overview to be able to look at the site and then make decisions. You can essentially leave notes for any work that needs to be done. So, for example, once again, going back to our pavement, if you want to actually look at the site again from this point of view, you can bring up all of the images that show that particular pavement, and you can go in and create those issues onto the images. And you can also leave notes. So if you wanted to leave a little note on the 3D model, and you can sort of say pavement issue, cross-check. And you can leave all the different notes that you want. You can give it an urgency level. You can sort of create a plan for repairs, and you can add more information over here over time. And all of this information can now be made available to the site owner so that they can have an understanding for what is going on site. And, this becomes a great way to be able to visualize what is the condition of the site, what are the different things that are going on site, and how do we actually bring all that information into a centralized place so that we can make decisions off the centralized place with the visual context with us at all times, as opposed to sort of going back and forth over things like email and not being able to track the information over time. All in all, hopefully this video was useful in terms of understanding the end-to-end workflow on how to create 3D models for large sites in Hammer missions. It's really not that complicated. All you have to do is capture the data in the right places, bring it all into Hammer missions, create your digital models, write your annotations, and yeah, one other thing that I haven't mentioned actually is that you can also use all of the data to create not just a 3D model, but also to be able to do measurements, because ultimately you also need to be able to plan works. And when you're planning works, sometimes what you need to do is understand how big structures are. So let's say you wanted to understand the repair for certain parts of this pavement. If you wanted to measure, let's say, the length of a crack, you can essentially do that. You can just click on this tool over here, and you can choose to understand the length of a particular crack. So you've got 4 meters of a crack over here, and you can essentially measure that. It's not just the length of a crack. You can also understand areas. If you wanted to do some work on the pavement, you can understand how big is that part of the pavement. So you can just draw your area over here and understand how many square meters is that particular area, or square feet. You can choose any of those 2 units. And then all of that is tracked for you in Hammer missions. Maybe you need to be able to actually create new parking spaces. And so to be able to do that, you can understand where to do that, because you've got now all of that information available at your fingertips. So again, measurements is a big application. And what you can also do in 3D is you can also understand the slope of different structures. So maybe you want to understand, have you got the right slope for different structures? And to be able to understand the slope, you can basically go in and measure the slope of any of the existing structures. So for example, over here, if you've got any of the slopes, you can basically go in and drop 2 points on the 3D model, and then you can essentially get the slope for that particular between those 2 points and sort of see whether that slope matches your requirements. So once again, you can actually do your measurements in 3D and 2D, and also look at your inspections. So once again, you can click on any part of this particular 2D map and then look at the images that show you that 2D map to build a better understanding for what's going on in site, what's needed, when, and how. Right, I've gone through quite a few things in that video, but hopefully it was an interesting way for you to be able to understand the power of drone data, to bring it all in, and how we can move the needle going beyond satellite images and actually creating a living, breathing copy of our sites, better known as digital twins, and leverage all that data for planning, for budgeting, for inspections, for all sorts of use cases, and essentially leverage all that data for much better decision making and ultimately move the needle forward when it comes to maintaining our sites in the physical world. Hopefully this video was interesting. If it was, do give us a like. We do create a lot of these workflow videos. If you have suggestions for some of the videos we should cover in the future, let us know. Thanks so much for watching. We'll see you in the next video for end-to-end videos at Hammer Missions.